All right, so here's our first PowerPoint on atoms. I'm going to go through it pretty quickly. If you're using this on your own, of course you may stop and pause and take notes and do the activities at your own pace. But since I'm just reading through it, I'm going to try and go through it pretty quick, okay? All right, so atomic molecular theory of matter. The atomic molecular theory of matter states that all matter is composed of small, fast-moving particles called atoms. These atoms can join together to form molecules. This theory is really thousands of individual theories throughout history that provide evidence for the whole theory as a whole. So a lot of people came up with little individual parts, and slowly those parts, kind of like a puzzle, came together to develop the big picture of this theory. Matter. Since the atom is too small to be seen even with the most powerful microscope, scientists rely upon models to help us to understand the atom. Believe it or not, this is a microscope. Even with the world's best microscopes, we can't clearly see the structure or the behavior of matter. We just rely on how things act around it to know what it is doing. Scientific models. Scientists create models to help them to visualize complex properties, structures, or behaviors. Since the atom is so small, scientists must gather indirect evidence, like I say, what's going on around it, to develop the model of the atom. This is a model of a very complex molecule made of many different kinds of atoms. Each colored ball represents an atom of a different element. And remember, elements are on the periodic table. So this is just showing how something can be put together and be really complex. So what should a model look like? Scientific models may not always look like the actual object. A model is an attempt to use familiar ideas to describe unfamiliar things in a visual way. So I picked this picture. This is by a young woman, by Pablo Picasso. It doesn't actually look like a young woman in real life, but you get the idea, right? You can kind of see long hair and her lips and her eyes. So you could guess it was a woman, but it's not exactly a true interpretation, not like taking a photograph. So is this really what an atom looks like? Many of the models that you have seen may look like the one below. It shows the parts and structures of the atom, even though we do not know what an atom looks like. Scientific models must be based on evidence, so they just can't make it up. Okay, the model over here represents the modern version of the model. It's an artistic drawing. We know there's a lot more going on now than when the scientists came up with this model that we still use in our textbooks. And if I ask you to draw the model of an atom, I would accept something like this. But this is showing something a little more accurate. Indirect evidence is evidence gathered without being able to directly observe the object. The atomic molecular theory of matter is based upon a vast amount of indirect evidence gathered over a long period of time. Just like pieces being added to a puzzle, each new bit of information gives us a better understanding of atoms, just like I said before. Can a model be changed? Well, a model can be changed as new information is collected. Like we used to have a model of Pluto because we knew it was out there, but we didn't really know what it looked like. But now that we've set a telescope out there that flew around it and flew by it, we now have a new model of Pluto and what it looks like and how it behaves. So from the early Greek concepts to the modern atomic theory, scientists have built upon and modified the existing model of the atom. So where did it all begin? Okay. The word atom comes from the Greek word atomos, which means individual, divisible. The idea that all matter is made up of atoms was first produced by the Greek philosopher Democracy? I don't know. If you know how to say it, let me know. In the 5th century BC. Okay, this dude right here. I wonder if that's really the dude or if that's just what they think he looks like. So the concept of atoms as proposed by that guy remains relatively unchanged for over 2,000 years. In the late 18th century, new discoveries were made that led to a better understanding of atoms and chemistry. Many scientists since that time have contributed new evidence for the atomic molecular theory. This is Niels Bohr. He is one of the many scientists that has given us a better understanding of atoms. He stated that electrons travel in a definite orbit around the nucleus. So before they weren't sure if it was in an orbit or if they just kind of floated on the outside. So he answered that question for us. Other thoughts on atoms? Let's pretend this information is in red because I didn't want to make up a slide. I found this. I thought it was a really good model. It was from another teacher friend. So Dalton's model, it's a solid sphere model or a bowling ball model, and it was proposed by John Dalton. Okay? John Dalton he discovered his information about 1803. Atoms were tiny. They were hard spheres that they can't be split up. So we couldn't really see them or know what was going on. By 1897, J.J. Thomas, he said electrons are distributed inside a positive mass like raisins in a plum pudding. So, or raisins in your oatmeal. You know, their electrons are floating around. Then along came Ernest Rutherford in 1909, that most of the atom's mass is inside the nucleus, and the electrons circle the nucleus, and most of the atom space is actually empty. This is an example of the present-day atomic model. James Chadwick discovered the neutron in 1932. The neutron is a subatomic particle that resides in the nucleus and has no charge. This model says that we can't know the exact location of the electron, but the electrons are more likely to be in a specific area of the atom. This cloud model shows the possible location of the electrons at any moment. Okay, nucleus contains protons and neutrons. The electron cloud is a visible model of the probable location of electrons in an atom. The probability of finding an electron is higher in the denser regions, where it's darker, of the cloud. So here I would like you to pause it, and in your notebooks you would go back to the previous slide and you would draw that model. Okay, and then I want you to label that model so you have it in your book and you can refer back to it as we talk about other things. When you are done doing that, make sure you submit it in Google Classroom that you did that model so you get credit for it, and then continue with this lecture. Atomic structure, the nucleus, key vocabulary word, the central portion of the atom. It contains the protons and neutrons. The electron cloud is the area around the nucleus where electrons are found. Electrons are arranged within the electron cloud in every level, in the energy level, sorry about that. Energy levels are sometimes called shells or orbits. Subatomic particles, we have the proton, which is a positively charged particle found in the nucleus, and we have the neutron there. Okay, it's the particle with no charge. It's also found in the nucleus. Then the electrons are negative charge subatomic particles found in the electron cloud. The atomic number or number of protons is identifying number of an element. Okay, so that's the number that would be down here. All right, it's the number of protons. The mass number, or the number of protons plus neutrons, are the number of electrons. Okay? So by taking the mass number, or the number of protons and neutrons, they will equal the number of electrons. So this is another one where you're going to copy the previous slide in your notebook and make sure you label it correctly. Okay? When you are done doing that, you may come back and do the next part of this presentation. It'll be on the next video.